Let's start the proof for problem number 8 in LR4-4. I can see that I know that angle A is going to be congruent to angle C. Those are here. So I'll list those in my given statement, and I also will have BD bisects ABC. So I'll have BD segment bisects angle ADC. And I've also have angle A is congruent to angle C. Those were my givens. So big whoop. It says that BD bisects ABC, but if I wanted to prove two triangles congruent, it's not a congruent statement. It's not something is congruent to something. But what does it mean if BD bisects ADC? Or ABC. Oops, I've got the wrong statement there. I'm trying to prove it bisects ADC. That's not what I want written here, because it's telling me that it does bisect ABC. So I have to change this. This is not what I was given. I was given that it was bisecting ABC. Okay, so this is the angle right here that's bisected. That's the one, which means it's split in half exactly. So angle 1 will be congruent to angle 2. That's what it means to be an angle bisector. That is your definition of angle bisector. Angle 1 congruent to angle 2. Write down definition of angle bisector. Okay. So, if I want to show that two triangles are congruent, I also have a shared side. So I know that BD is congruent to BD. That's also known as the reflexive property. Look at yourself in a mirror property. You're the same height either way. Okay. And it looks like angle A and angle B are marked in angle ABD, and the side between them is not marked. So this is going to be side angle angle. This side is not between the angles. So we can state that angle ABD, or triangle ABD, is congruent to that other triangle, which is ACD. Okay, great. Now the only thing I can say, when I know the two triangles are congruent, the only thing that I can say after that is that I have a set of congruent parts. Something will be congruent to something. If two triangles are congruent, then, oops, I forgot the congruent, then their corresponding parts are congruent. Well, what corresponding parts would give me DB bisects angle ADC? Because that's where I want to end up. I want to have an angle bisector. This time I want ADC. So if I want DB to bisect ADC, well, here's angle ADC. If I want this to be an angle bisector, what would it have to do to this angle right here? It would have to split it into two congruent parts. So, angle 3 congruent to angle 4. They are corresponding parts. And that would be true because that's the definition of angle bisector. Anytime you have a something is a something, DB is an angle bisector, you are rationale will be definition of angle bisector. And that's the proof for problem number 8.